Guys, welcome back to another video. So this is our 8th lecture of Java Complete JS Mastery series. So in this lecture we will be discussing about prototypal inheritance versus classical inheritance, abstraction and encapsulation, and polymorphism. So basically we will be talking about the OOPS concepts, right? So how exactly prototypal inheritance in JavaScript is different from classical inheritance? That is the first topic that we are going to see today. So, firstly, let's talk about OOPS. What exactly is OOPS? So, uh, OOPS is based on one core principle, that is abstraction. Hide. What does abstraction means? Abstraction means hiding unnecessary details details of something, right? So this is what encapsulation means. Basically abstraction means. So and there are three basically pillars that we implement in order to achieve abstraction. So there are three pillars of OOPS that we implement to achieve abstraction. So basically, suppose you are having a car. So car is made up of several different things. It has a clutch, accelerator, brake, steering wheel, driving seat, and conductor side seat, back seat. So roof, windshield, wipers, indicators. So there are several different things. So we do not need to dive deep into those things in order to work with our car, in order to drive a car. But we need basically the abstracted layer, that we expose some part of the car to the user, so to the driver, so that he will be able to drive the car. So basically you hit the clutch, change the gear, then put on the foot on the accelerator to increase its speeds. So do we need to know internally what exactly is happening, how the fuel is coming up, how it is getting converted into mechanical energy? Do we need to worry about these stuff? Absolutely not. So there are some things that are being exposed via the manufacturer, that we can handle on our own, that the user can use those features to drive the car. So that is exactly what is meant by abstraction here. We hide the unnecessary complexity of something in our code and expose some behaviors, so that he can use those behaviors in order to achieve whatever needs to be done. So right, that is the core principle of OOPS, that is abstraction. And how it is implemented? It is implemented via three pillars of OOPS, that are inheritance, polymorphism, and encapsulation. So these are three fancy terms that are being used to implement the abstraction principle of OOPS. So that is what we are going to see today, how exactly inheritance, polymorphism, encapsulation, and abstraction are working in JS, and how is it different from classical inheritance that we see in modern programming languages such as Java, Python, C#, and C++. So how does it differ? How does JS differ from these programming languages in terms of inheritance? So let's just quickly write the code down. So I will write the code in Java and JavaScript, and you can compare them. Inheritance.java. Right. So let me create a class. Let's say dog, function dog. So we need to use the function constructor, right? So it can have a name, it can have a breed, and we can define this like this dot name equal to name, this dot breed equal to breed. And we can also define a function in prototype, dog.prototype.speak We need to use the function declaration. We cannot use arrow function because they do not have access to this. They take it from the lexical parent. So lexical parent will be having undefined in this basically window in the case of browser, and object, global object in case of Node.js. So this will point to that, not the current object. So that is why we are using function declaration instead of arrow function. So we will say this dot name barks, right, or speaks in this case, because we are using the speak function. Speaks. So let's say name it as animal instead of dog. Animal. And instead of breed, we can discard this field breed, and animal dot prototype, this dot name speaks. So now how do you create another function constructor that inherits this constructor? So in order to do that, we need to declare another function constructor which will have name, breed, and what it's gonna do is it's gonna call the animal constructor. Now how exactly we are going to call is using something known as call method. So you define the function that you need to call, then you use call, then you pass an object on which it is going to be called. So you will pass a this, and you will pass name, and this dot breed equals breed, right? So what exactly is happening over here is it is gonna call this animal on this object. So this will be passed when you create a dog object. That object will be passed inside this, and it's gonna change the name of that particular object to this name, right? So that is what is gonna happen. So I will write a dog object. Let's say Labrador. Let's call it Rocky, and breed is Labrador, and we wanna print the Labrador dot name. So how is this Labrador dot name? So, right, we are creating a constructor object out of it, of the dog class. It is not having this dot name equal to name. It is using its parent function constructor to initialize this field, the name field for itself. That is being handled via something known as call. We will dive deep into call, apply, and bind in the upcoming videos. But for now, let's just understand that what call does is it calls a function based on an object, and it passes some parameters to this. So this is the function. This is the object, that is Labrador, and we are passing the name, that is name. Rocky is being passed. So the name it will inherit from the parent, right? We can see that it can print out name. If we comment out this line, then we won't be able to access it. We will be getting undefined. Right? So we have to do this in order to set the property name using the call method. So how right? So this is how you basically call the parent function. There is nothing such as nothing such as constructor or super keyword in order to call the parent method. You just need to use the call method in order to call the parent constructor. And how do you basically access this speak method? Because speak is not defined inside the dog function constructor. So will it be able to access it? No. So if I do something like Labrador dot speak, output would be error. We will get an error because Labrador dot speak is not a function. So how can we create a prototypal inheritance? So we can do something like, if I try to copy and paste it inside the browser, right, so it will say speak is not defined, not a function, right? So what we can do is, if I try to console dot dir dog. So it will give me a function and say its prototype is having a proto which is linked to an object. So what we can do is we can do something like dog dot prototype dot underscore underscore proto equal to animal dot prototype. Now it is this prototype dot proto will start pointing to animals prototype, and in animals prototype we have defined the speak function. So now it will be able to access the speak method. So what we can do here is we can define something like dog dot prototype dot underscore underscore proto equal to animal dot prototype. Now it will be able to access it. How? Because inside the dog's prototype we are having a proto. Now proto is, now if I write console.dir, it will show me the structure of the dog, and it will start pointing to animals prototype. This prototype dot proto is started pointing out to animals prototype. Like earlier it was pointing to object, now it is pointing to uh, animals prototype. So now you will be able to access the speak method. Now if you hit run, then see it is printing out Rocky speaks. So this is how you do prototypal inheritance in JavaScript. Now how does exactly it differs from inheritance in other object oriented programming languages? So let's just see that. So we will define a public class, let's call it as animal, public class animal main method, and it is having, let's say, name animal. Now we have to define the constructor of it. So it will receive name, this dot name equal to name, and we have to declare another class name called as dog, which will extends the animal class. What just happened? Implicit, okay. So we need to define the constructor, public, right. Okay, we need to define it as public to expose it to the other classes, right. So this is how it works in object oriented programming languages such as Java, C#, and C++. We define a constructor, then in the child class we define a constructor again, and we call the parents constructor using super keyword, and we refer to the fields using the super keyword. So we use extends to inherit the class, and we use super to refer to the properties of the parent class. So that is how it is working in the object oriented programming languages such as Java, C#, and C++. Now they copy the whole properties inside them. So what happens over here is, or in object oriented programming languages is, so let's say we have this animal class, inside this we are having name, let's say this 4K, and it belongs to animal, and now dog is extending animal class. So what will dog have is, it will have a name, and what else it does, it has an animal function, animal constructor is there. Do we okay, we need to define public static void speak, s out, this dot name speaks. Okay, we cannot, yeah. Right, this is our animal class, no need to define main method over here. So it has speak and name, speak function. Now what properties will this 6k address that is being defined by a dog? So it will have access to name, it will have access to speak, and it, let's say, public string breed, and it will accept string breed, and this dot breed equal to breed Labrador, dog dot name, dog dot breed, dog dog speak. So it will have breed, name, speak, breed, and speak fn. Right. So it will copy all the attributes and the methods inside this object, inside its basically class. When you declare the object, it can refer to the parents object and methods using super keyword and constructor using super keyword, right? So this is how inheritance is working in case of object oriented programming languages such as Java, C Sharp, and C++. Now, how does prototypal inheritance differs is, so this is example of classical inheritance. So I will erase this guy out. Classical inheritance. Now, in case of object oriented, we have, what do we have? We have animal and dog functions. Animal dog dot prototype dot underscore proto will start pointing to animal dot prototype. So it will start pointing to animal dot prototype. So it will not copy the properties and methods inside of this function constructor, but it will create a proto property when we define using, which we define using dog.prototype.proto equal to animal.prototype. So it will do a prototypal chaining. Basically, it will have the object referencing to a animal's prototype. It will not copy the methods and variables inside the function constructor. So that is how classical inheritance is differing from prototypal inheritance, right? So if I type out something, let's say use ChatGPT, which languages supports prototypal inheritance and which supports classical. Prototypal inheritance is supported by JavaScript, Lua, and Self, whereas classical inheritance is supported by Java, C++, C Sharp, Python, Ruby, Swift, C, Objective C. C is not supporting any classes and inheritance. Right. So this is the difference. Object inherit directly from the other objects, object delegation, based on the classes and instantiating objects. So you need to instantiate the classes, then only you can do the inheritance. Inheritance happens by classes, not through linkage. So that is the difference between prototypal and classical inheritance. Now we'll be talking about something called known as abstraction and encapsulation. Abstraction. Suppose we have a function constructor as bank, and we want to create a basically a method variable that is private to the bank, that is being not exposed by the bank. So how do you define a private method inside JavaScript to achieve abstraction? There is nothing known as private. There is no thing that you can use to declare private, but in the function constructor especially, but it is supported inside ES6 classes using the hash symbol, but we do not have anything to support the function constructor variables to make private. So what we can do is we can define it using let balance equal to 0, and we can define bank.prototype.deposit equal to function, right? And we can withdraw the amount using prototype.withdraw function amount. If amount is greater than 0 and amount is less than balance, then we can debit the amount, right? And what if we want to access the balance? Then we can expose then what we can do is this dot get balance equal to function return balance. You can do something like this, right? So if you define where my bank equal to new bank and deposit this amount, then you should get 100, and you won't be able to access my bank dot amount balance. It will give you undefined since it is not being returned, right? New bank is creating an object, and object is not having, it is not defined using this dot balance equal to balance. It is not defined like that. It is defined using let. So in the object you will not have any property, because we are not defining anything inside this using this. You will only have this method inside this object, so you will get undefined. Okay, yeah, okay, this dot balance, am I doing it right? Okay, you need to define these variables inside, okay, inside the function constructor itself. Let's skip that for now. Okay, let's comment out this one as well, right? You will see undefined. So to withdraw and deposit, you can do something like this. Right. Right. You can use get balance method to get the current balance, but you cannot use dot balance to get access to this property. Although you can access it like this, bank dot balance. You can access it like this. There is no, okay, it is not allowing me to access it. Okay, yeah, it will not have access to this property, right? Because we have defined it using the let keyword, not like this dot balance. If you define it like this, then you can access it. Okay, I will comment on this. Then you can access it. 0 and undefined. Yeah. So if you define it using this, then you can access the property. But if you define it using let, then you cannot access it, because uh, in the object it is returning this, and this is no, balance is not defined via this keyword. So that is why you will not be able to access the balance property straight away. So this is how you create a private variable inside JS and achieve abstraction, right? We do not have to expose this balance to if you want to expose this balance, we will just return it from a function. So you cannot modify this balance, right? This is what abstraction is. Now let's talk about overriding. So we will use the same example as in case of animal and dog. Now let's say we want to explicitly define a speak function inside our dog class. How do we do that? That will be done using dog.prototype.speak equal to function. So if you try to access speak now, it will hit this speak, not animals speak. Rocky barks, not speaks. If you comment out this one, it will take the go through the prototypal chaining, and it will find speak method inside animal class, animal function constructor. Then it will do Rocky.speaks. Otherwise, you can override this method. So this is called as overriding a method in JS. Creating private variable. Prototypal inheritance. So I think we have covered everything now. Just the polymorphism is also done. There is polymorphism compile. There are two types of polymorphism: compile time and runtime. So we have discussed about the runtime polymorphism. Like we have done the overriding. Overriding just basically means runtime polymorphism. At the time of runtime, it will decide which method to invoke. So this is called runtime polymorphism. Runtime polymorphism. Okay. Now, how do you use method overriding? Like if we have main.java, inside Java we can do overriding, method overloading. So let me define a function such as public. Let's make it public static void sum int a return a. Public static int sum int a b return a plus b. Now if I call int result1 equal to sum sout result1 int result2 equal to sum 1 comma 2 sout result2, then this sum will hit this method, and this sum will hit this method, right? So if I do run Java, it will give me the output as 1 and 3, because 1 is simply being returned, and 1 and 2 will make 3. So right, so this is called as method overloading. Method overloading example. Right, so how can you define it in JS? In JS, there is no way to do method overloading, because every time you define a function, it will be overridden, because it is having the same memory reference, right? It will not create a new memory reference for that. So you can do something, use something called as arguments in order to do mimic such type of behavior in JS. So overloading.js. So function sum. So if arguments dot length equal to 1, then return arguments dot 0, else return arguments of 0 plus arguments of 1. So you can use this. So if I invoke it, result equal to sum1, right? So you can use something arguments that will carry the arguments that are being passed in form of an array, right? So you'll get 1 and 3. So there is no way to do method overloading in JavaScript. There is no possible way to do it, right? So yeah, so that's it for this video. We have covered each and every oops principle, right? In the next video we will be talking about this guy over here. Where is it? What was the name? I forgot. Okay, call. This guy, call, apply, and bind. So we will be talking about these things, and we will see what is coming up next. So we will in the next video. For the next video, let's stick to call, apply, and bind, and some popular interview questions in JavaScript. So that is what we are going to cover in the next video. So that's it for this video. Thank you guys. In the next video. So that's it for this video. Thank you guys. In the next video. So that's it for this video. Thank you guys.